Okay. So this is question number 4 from the given sheet. So the volume is area of base into height. If you cut a square from the all 4 corners, okay, then this square will be bending up. So the only base which is left is 15 minus 2x into 8 minus 2x. And the x will act as a height. So we can write the volume as 15 minus 2x into 8 minus 2x into height. Okay. So let's multiply this 120 minus 30x minus 16x plus 4x square all into x. Okay, so v equals to minus 46x plus 4x square into x. So v is equals to 120x minus 46x square plus 4x. Now this is the volume. Now what is the question? You want to maximize the volume?
Sir, we can
Yes,
put
so we have to first derivate then
by
equal to
derivative,
0.
yes, sir.
Correct. So to maximize the volume, because volume is a function of x, volume is a function of x and you want to maximize it. So what you will do is you will differentiate with respect to x, right?
The answer will be 120 minus 92x plus 12x square.
Into 90, 2x plus. So this is like a quadratic equation, and if I equate to 0, we have to solve for quadratic. That's very bad quadratic. Doesn't look nice. So maybe I can give you.
So we can divide it by 3 and then simplify.
So
Yeah,
yes,
because yeah, that will 92.
so it's 92.
So we can't divide by 3.
So
by
we
two
can
we get
apply the quadratic formula.
Yeah, so that is the only way I look like, but I wanted it to be like somewhat simpler. So let me check just at least we can divide by 2 at least as of now. 6x square minus plus 60. So this is what we can do, and we can divide by 2 more, right? So 4 is better. 4 is better actually. Okay, we could divide by 4 actually. My pen just. Yeah. So now we can actually divide by 3x square minus 23x plus 30 equals to 0. Now this is fine. This looks fine because we can write this as this minus 15x. No, 15.8. That's too much. 13,390. So I think chances little chance. 90 we can get into
We can
23.
write 18 into 5, sir. 18 into 5 is
Yeah,
9.
yeah. 18 to 5 is the working. Yes, correct. So now this will work. Now this will definitely work. So we can take 3x common. X minus 6 and x minus 6 equals to 0. So now this is perfectly factored. So we have this answer. Now definitely you will get two answers. One is this and this. This we cannot have. This is impossible because if you subtract 2x from 8, you will get a negative value, which means it's not possible. So 8 minus 2 into 6 is minus 4. So we cannot take 6 as the right answer. So only possible answer is x equals to 5 upon 3. So we got the dimension of x. So you can find the rest of the things like the length will be now 15 minus 2 into 5 by 3, which is 45 minus 10 is 35 by 3. And width is 8 minus 2 into 5 by 3, which is 14 upon 3. So we got all dimensions. So this turns out to be 35 by 3. This turns out to be 14 upon 3. And of course, x we got as 5 by 3.
Sir, they gave dimension of cardboard which is 8 inches wide and 15 inches.
Correct.
So, but we have to find the volume, no? Maximum.
Yeah, so we have to find the volume. We have to find the dimension actually, which can have the maximum volume.
Yes, sir, dimensions they have asked.
Yeah.
Ah,
So
yes,
if you have the, it's a typical question of matchbox. So if you open the matchbox, you will see the same. If you open the matchbox, the inside part is exactly triangle, like open from one side and covered from the other side. And if you break it, you see the squares are missing from the corner.
Sir, I got the same answer first when I started. 6 and 5 by 3.
If you break it from the corner, and then also. So you can tell me which question you want to solve. I will just try that question.
Sir, can you solve the 9th one?
So can you solve the third one?
So because in 9th it is asked to find the minimum, the dimension to for the minimum post. I mean minimum value.
Sir, here we means f double dash x will be greater than 0. So in that minima will become no.
Which one you're talking about? Which question you're talking about?
So first will you solve
So
third one because
9th one.
it's one.
Sir, in 9th one, how to solve? So we will try.
Just a minute. I'm moving. Yeah. Question number
Third.
9.
third.
Third and 9. 3 and 9.
So first, start with third. Find the area of the largest rectangle with lower base on the x-axis and upper vertices on the curve y equals to 12 minus. That's nice. So, okay, why we are not able to solve this question? First of all, the y is given as 12 minus x square. So we need to understand what kind of shape is this. This shape is.
Sir, it is O.
Sir, it is a
It's a downward opening.
Yeah, it's a
no,
downward.
it is
Correct. It's a downward parabola.
inflection.
Yeah. No, it's a downward parabola. That's it. It's a curve which is downward. That's it.
Sir, but I have seen it is in
A is negative.
say I had seen it in GeoGebra that graph, but it is showing it is downward, upward, concave.
Yes. In GeoGebra, you can see it's a downward parabola. It's a downward parabola, and if x is 0, y is 12. So
A is negative. That's why.
Yeah, because the a is negative, correct. So now if you plot it, then you'll get the better idea. So let's say if you're plotting it, you will get and when x is like 2 root 3, you'll get the 0 answer. 2 root 3 will be 0 because if I put it, y will be 0. So, okay, wait. This is the maximum value because it is y minus x square. So this is a graph which is symmetrical. If you plot, even if using the GeoGebra, you will get something like this. And you can easily find that this is.
Sir, but if we put x is minus, yeah, it will be the same graph. Yeah.
Yes. So this is the graph you are going to get. Okay. So it's a symmetrical. Okay, and it is symmetrical about origin. And now the question is, where is the question? The largest area of rectangle. So of course, to make it largest, you will make a something like this. So you may want to make a rectangle using the x-axis as the base and then touching the y-axis. So the y, you can see the vertex of the rectangle. The upper vertex of the rectangle is touching the curve. Can you see that? Here, and this is the base touching. Now, because it's a symmetrical, so I can easily find something. So if I say this is x by length, this is y by length, so this height will be how much? 12 minus x, right? And technically, this is also x because both are symmetrical. So now, because we have x as the value of one side and the height is 12 minus x square, so the total area will be how much? What is A? What is the total area?
So 2x times 12 minus 6 square.
2x times 12 minus 6. And you know how to do the next part. To
So,
maximize the area, you know what to do.
so now we have to create a equation then equate to 0 and
Yeah, you have to
differentiate.
differentiate. Correct. You have to differentiate and equal to 0.
Yeah, so
So just try this. Try this. I think you will get it now.
after differentiating, we have to put x is equal to plus minus 2.
Yes.
So we have to put x is equal to plus minus 2 in plus in different plus in different function and minus in the same function, right?
So plus and minus 2.
You
So
take
x is equal to plus minus 2.
You take plus 1 because the x is value, no?
So
Yeah,
plus 2.
It's plus 2. It's not mathematics, it's a rectangle, it's area.
So length is 4 and height is
so y is equal to 8.
8.
Right.
So sir, answer will be 32. 4 8s are 32.
Correct.
So if you have to find the minimum area then
0.
okay.
Don't draw anything. So for minimum, you're not supposed to draw anything. You get 0 area. Right?
Yeah, sir.
So see, every question will have a constraint, and what you need to realize is that there is a very obvious logic why they're asking maxima, because the minima is meaningless. Okay, so when they ask minima, it means the maxima is meaningless. So they are only, see, in only mathematics you will come across where we have to find both. In physics, I won't say everywhere, but in physics, 99.99% case, when they ask maxima, it means only maxima is possible. When they ask minima, it means only minima is possible. Okay, so both can be possible at the same time. In physics, that is what happens. In mathematics, because we have polynomials, we have equations, so everything is possible. We can have maxima and minima at different points. So if you are getting critical point only one value, and they're asking maxima, it means the answer is maxima. You need not to check the maximum. If we get multiple critical points, then there is an issue. So let's say I'm getting 3-4 critical points, and then I have to really check which one is the maximum, which one is the minimum. But if I'm getting just only one value, which is physically possible, let's say here x is plus 2 minus 2, but minus 2 is meaningless because the length of the rectangle cannot be negative. So the moment I have the x value, which is only one value, so I will get only one thing, which is maximum, not the minimum. Okay. So which next question?
So 9th one.
So I solved the 9th one.
So you got the answer?
Yeah, so
Okay.
sir, are you asking the answer?
No, I'm just reading question. Yeah. Okay. Our poster is to contain 15 square inches of printer material with a margin of 4 inches on each top and bottom, and 2 in the left hand side. Okay. So find the overall dimension of the total area of the poster is minimum. Okay, just okay, fine. So you have to assume some rectangle of length x and width y to begin with, and what is given is the area is given. So you know that x into y is fixed. So what is x into y?
50.
Correct. So first you read the 9th question. So you will start with some random paper. This is your paper. Okay.
Sir, 2 minutes I will try again and then
Yeah.
I will tell you.
Okay, okay. You guys start. I'm giving you 5 minutes.
Sir, in the ninth question, it is okay if I use partial derivation.
In ninth, you want to use partial derivative, so you want to keep x and y together. Yeah, that's fine. You can use that. That is also a way of doing it.
Sir, 50 is the minimum area, no?
50 is the total area of the sheet.
Of the post. I mean,
No, no, no,
printed
no, no, no.
thing.
Wait. 50 is the area on which you have to print. So it's a left out area after the, you
Cutting the margins.
margin. After margin, the area left is 50. So the question is how much I should take x and y so that I can make it 50. Okay, so what is the minimum dimension which can give me 50 printable area from the given area?
Sir, yes, you told that you will solve it out in the next lecture. Sir, that partial derivative.
Okay, that I will do. You do by the regular method, and I will show you the alternative way of solving the partial derivative method. So just leave it as a. You do by the regular method, which you know already. So you can start with, let's say, x and y is the actual length and width. Then you cut the margin by as said in the question. Then what you left with, you find the area and equal to 50.
Sir, no, I know that how to solve partial derivative, but I just had one doubt. Sir,
Yeah,
that uh, sir, partial derivative formula is, sir, what comes up? Del x or del y comes up first?
the
That
upward
was
up is x.
okay, sir.
It's a reverse.
And
Up is x.
del x by del z.
Yeah. Del z by del x upon del z by del y. Minus with minus and okay, so minus is there. So that's why I always say that after every lecture, try to make a notes of your own, okay, so that you can go and refer to the notes. Because even going to the video is not very much, easy. It's a tedious task going to the video, watching the entire video to find out where I left, where I missed something. And whenever I'm teaching something, let's say you're learning and you find out, okay, this concept is pretty difficult. So always note the lecture date and the time at which I'm saying that thing. So if you want to go back to the video, just go back to the video and scroll, slide the time to that time, okay, stamp, and then watch the things which are related to you. So these are some tricks you can keep in your mind if you want to watch videos later on. Always make a like a list of time stamp, like where you want to learn something which is difficult part. So you just note when I'm saying this, because it's a 2 hour video lecture, 2.5 hour video lecture. So you want to directly go to the something of your interest. So just note down the time. Okay. So let's say I am
So
solving this
and
problem.
del z by del x. So I take x as constant, no? Here, and y is variable.
Why? No. Yeah, correct. If I did partial differentiating,
Yes, sir.
yeah. So if I differentiating with x, then y is constant, definitely. Okay, I think I should solve now.
I got the answer.
Okay, very good.
So 19 inch.
So 19 and 8. How much?
19 inch.
19. That's a height. Okay. So find the overall dimension. So the dimension you're taking is rectangle or square. It's coming as rectangle.
Yeah, sir, rectangle.
So what is the length?
Sir, for length it is I took x, and for breadth
Yeah,
I
just
took.
just tell me the two values, x and y values. What you are getting x
So
and y?
first x, my x, I got x as 15 and y as 4. So after adding them up, I got.
Okay, so let me just check the answer. The answer for ninth is 18 and 9. 18 inches and 9 inches. The height is 18 and width is 9.
Sir, I got different answer then. I got 15 and 4.
Maybe something is missing.
Yeah,
Okay.
sir. Yeah, I got it. What I had done wrong. Sir, I had put a dash and xy dash in minus 50, as you said, and then I forgot to eliminate 50.
Oh, yeah. So now just eliminate. Tell me.
Sir, then I got y dash as minus y by x.
So don't use wider standard. You just differentiate. Why you're doing this? I mean, I don't know. What I said is you solve, just you find dy by dx and equal to 0. And you have to make the thing into one variable from the given condition, because if I say this is x and if I say this is y, so what they are saying is that remove 4 inches from the top and bottom, right? This is what they are saying. And they are saying that remove 2 inches from the left. So this is the printable area. What is the printable area? This is the printable area, right? This is the area which you are interested. And this should be how much? 50. Because it's a how many? 2 inch. This is 2. This is 2, and this is 4. Just to confirm. So how much area we have to exclude from the total area? So we have to exclude 4 into 2. 4 into this is how much? X. So we are removing 4x from here. This is the 4x area. This is also 4x. And what is this area? This is y minus 8 into 2. So I'll just show the area first. So this area is how much? The pink area we have to remove, right?
So y into 2.
So it's not y, it's y minus 8.
Okay, you took the y a whole. Okay.
The
That's
y
fine.
is, yeah,
It is
so y minus. So this
18.
is y minus 8. Oh, that's very, very bad of me. So, okay, anyway, this is y minus 8 into 2. Because we have 2 times, so this is also y minus 8. So now I can say that from the total area, which is x into y, I have to remove 8x and I have to remove 4 times of y minus 8. And when I remove all these things, what I am left with is 50. So this is the information which I have. And then I think I can simplify a bit. This will go, this side will become 18. So what we have is, I can take x common here. So I'll get y minus 8 minus 4y is 18. So I can add x into y minus 8 equals to 18 plus 4y. So x is 18 plus 4y upon y minus 8. So at least I am able to remove x in terms of y.
Sir,
Yeah.
sir, what did you do after diagram? I was not able to hear you because your voice was cracking.
Okay. What I'm saying is that after removing the margins, how much area is left?
Okay, sir. हाँ समझा.
So the pink is the margin which we have to remove, and blue is the printable area, and that area should be 50. Okay. So now we got the relation. The x is this much, and the total area is how much? X into y. So I can write x as 18 plus 4y upon y minus 8 into y. And I want to minimize the area, so I will differentiate with respect to y. So we can use the quotient rule. So if you know that u by v differentiation, which is u dash v minus v dash u upon v square, and when you equate to 0, just a moment. When you equate to 0, what you get is u dash v equals to v dash u. So instead of writing the entire thing, you just write this part. So can you do the same thing for these 2 terms? And equal to 0, if you equal to 0, you get the same. So what we can write from here is, if you can understand what I'm writing. So u dash, the numerator differentiation, u dash is 18 plus 8y into v equals to v dash, which is minus 8. Which is minus 1. If we differentiate the denominator, we will get minus 1. Sorry, not minus, plus 1. Plus 1, yeah. So anyway, this is not required. So 1 into the entire. So now this you can solve by multiplying. So 18y minus 18.8, how much? 18.8 is how much? 118. 144, sorry. 144. I don't know mathematics. So 8y square minus 64y equals to 18y plus 4y square. Okay, that 18y will cancel out. That's nice. So out of 4y square, 8y square will cancel out, so 4 will left. So I don't have space to write further. So probably I should write in the next page. Go to next page. And you guys can remember what I have written here so that you can tell me what I'm writing, going to write. So minus 144. Then what was next? Minus. Okay, so I've written correctly. So now we have 4y square minus 64y minus 144 equals to 0. And probably we can take 4 as common. So y square minus 16y minus. Okay. So what we can write 16. Okay. 36. 9. Nothing will come.
Sir, 18 to and 18.
Yeah, 18. That's right. So I think we are going to get the answer which we are looking for. Y square minus 18y
So
plus
minus
2y.
18.
So y minus 18 plus if you took on y minus 18. So this will give you y plus 2 into y minus 18 equals to 0. But we know that y cannot be negative because we are taking the dimension. So y cannot be equals to minus 2. So we must take y equals to 18. So we got the dimension y equals to 18. And since y is 18, so we can say x equals to how much? We have the formula for x if you remember. This is the formula for x, which is 18 plus 4y. 18 plus 4y upon y minus 8. So let me substitute 18 plus 4 into 18. 18 minus 8. If I take 18 is common, I can get 5 upon 10. So this is 2 and this is 9. So we are getting the perfect answer. So our answers are x is 9 inches and the height is 18 inches. So this is matching the answer.
Yes, sir. Sir, can you show the previous page?
Yes. So it's a lengthy one. Of course, it's not very easy. But I'll try to make it. Okay, let me do it in another way, which can make it easy. Hopefully.
Sir, 2 minutes. I have to know. I will take the focus.
Yeah.
Sir, I
Yes.
also did the same way. I got y minus 4 multiplied by y minus 4 multiplied by x minus 8 is equal to 50 for the equation.
Y minus 4.
And x minus 8.
X minus
I
8.
also took the same thing.
No. So the idea is, see, you cannot take the if you take this rectangle, then this rectangle will reduce in size, right? This is less small value. So what you guys are doing mistake is you're taking this area double. You're taking this area double.
Sir, no, I consider length as x and breadth as y. That's I
No, sir.
That is meant.
Sir, yeah, sir, you are right, sir. We are taking that double. Y minus 8 and x minus 4. X minus
Yeah.
4 includes that double.
Correct. That's why the problem is coming.
Sir, but then we can minus it by 8, 32. The whole value by 32.
So
So
no,
see,
when you cut the upper part and cut the lower part, then you are left with only this area, no? This two area. So you have
yes,
to remove.
but we can minus it by 32 because 2 into 4 is equal to 8 and 8 fours are 32. So negative minus 32. Y minus 8 into x minus 4 minus 32.
What you are saying? So this is a x. See, I have this much area total. From here, I remove the upper and lower, which is 4x and 4x. And then I remove the side, which is 4 times y minus 8. And then what we are left with is 50. This is very, very important.
So this is the same equation for that only, no, after multiplication of y minus 8 into
No, 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 no,
no,
no,
no.
no. That is not the same.
Sir, what I'm saying is
What I'm
that
doing is I am
corners.
removing the margin from the actual area to get the printable area.
Okay, sir.
So this
Hello,
is the
sir.
yes.
So as you said that we took the both all the corners double, so we can minus the all the corners one time from the values that we get, which is 32, because 4 into 2 here will be 4 into 2 is 8, so 4 times this corners will be 32, and we took it twice, so it actually will get the all
So
the
you have to
area of
you have to
all the
add it.
corners is 64 minus 32 is 32. No, sir.
You have to add actually.
Yeah, sir. We have to means the total value will be 64, and we will minus it by 32, and then we'll get 32 plus 32.
So what is your what is your equation? What you're getting here?
So I'm
Sir,
getting is y minus 8 into
sir,
x minus 4 into sorry, plus 32.
So
sir,
what
may
is
I
this
know my
equation?
equation?
So the same equation we are getting.
Sir, we are getting the same equation, but we consider length as x and breadth as
Okay,
y.
that is
That's
fine.
why.
That's not an issue. That's fine. So if you're getting the same equation and if x and y are
Okay,
interchanged,
sir.
that's not an issue.
Same answer.
Okay, no problem. But can we do it really easy? Because this has taken lots of difficulty in writing. Okay. So let me see if we can do something there. So removing the first part, removing the second part, can we solve in when we have two variables? Yeah, I hope so. We should be able to solve. So this is a small area I'm removing. Okay, so what we can do is you can start with this way. Assume the inner size. You may think this way also, because addition is easier than subtraction. You know, in most of the cases, we like addition than subtraction. Like, so what if I start with this as x and this is y? So the outer length will be x plus 4,
Yes. And y plus 8.
and this will be y plus 8. And what is given is x into y equals to 50. That's easy way of it, right?
Yes, sir.
So now this is pretty easy. So now we know that the actual area is x plus 4 into y plus 8, and I think that's easy. Now we can do it much easier than before. So if I multiply both, I'll get xy plus 8x plus okay, 8y plus 4x, xy plus 8x plus 4y plus 32. And
And
we know
x
that,
y is 50.
yeah, that's 50. So a is okay. But again, we have two numbers, like we have number and 8x and y. So we can replace y as 50 by x. That's easy. That's quite
Yes.
easy, right?
Yes.
From here. And now differentiating, this is like a piece of cake. This is 8 and minus 50 by minus 100. This is 200. Yeah, 50 to 4 is 200 by x square. Is this right? 8 minus, just confirm, 4y. So if I equate to 0, what I am going to get? X equals to 25. Is it x equals to 5? 5? That's nice. So we got the answer. X is just 5. And because x is 5, so y is how much? 10. Right? So the outer dimension is how much? X plus 4 is 9 and y plus 8 is 18. So we got an answer. So how easy is this? So compared to the previous one, this is very
Sir,
fast. Yes.
sir, but 200 upon x. Sir,
Square.
how will you differentiate it to 200 upon x?
The 200 is number, you can take it out. And what is the difference d by dx
Constant.
of x power minus 1?
So one. Ha. Sir, it would be minus. Ha, sir, right. Sir, but it would be 1 upon minus 1 upon 2 root x, no? Differentiation of x raised to minus 1.
So actually internet has gone, so I'm just trying to reconnect.
So can we try 10th question?
Yes, you can try.
Just
Sir, but
screen
differentiation of sir, but differentiation of
Yeah,
x raised to minus 1 is 1 upon 2 root x, no? So 1 no. So no 1 upon root x, sir.
No, sir, it will be minus 1 upon
just
pi square.
just a moment. I'm like, okay, just a minute.
Oh, ha, sir, minus
Okay,
1
I
upon
got
x
this.
square.
Yeah.
If it was root x, then 1 by 2 root x.
Yes. Yes. Correct. Correct. See, differentiation is something that you should not leave. I mean, rather, I would suggest that keep on practicing as and when you get some time. Don't leave it for a long time. Else it will be difficult for you to continue with the concept of calculus. So my suggestion would be like go back, solve some question, come back, and if you in case you're forgetting the formula, revise the formula, and that should be a regular practice. It's not one time that you learn and you can remember forever. So it's something which you have to be in practice all the time.
Sir, please
So
can you
can you
show
show
the
the solution
slide?
of last one?
Actually, we have lost all the screen because whenever there is a disconnection, the screen is lost. Okay, so
Sir, so
although you
can you
get the
solve
entire
after the
video,
differentiation?
Sir, after
After
you can get the
differentiation
entire
of
video.
minus 400 by y square.
Kept on cloud. Pardon?
Please
Sir,
can you show
can
the
you just
difference
solve
of
the last 3
a dash?
steps? Because I had to just note the last 3 steps.
You guys voice is cracking. Voice is cracking a lot.
Sir,
Sir,
I have to write
Just a moment.
just a last.
I can't listen to any one of you because it's cracking. Net has again. Some issue is there, I think. What is the issue?
Hello, sir.
Yes, I'm listening. Actually,
Sir.
there's some network issue.
Okay, sir.
Just a minute. I'm trying to reconnect. Now it's coming. Okay. I hope we should continue now.
Sir, I have one doubt.
I don't know, but your voice suddenly started cracking a lot. I mean, maybe it's problem from my end, but if it is persisting, then you can connect and come back.
Sir, now is it correct?
Yes. One of you, I mean, yeah, it's cracking actually. My voice is cracking.
No.
Am I audible to you guys clearly?
Yes. Yes, sir.
Okay. Okay. Okay, it has gone again. Yes. So I think this question is done. Okay, you need something more, or we can go to the next problem. Okay.
Sir, I have a doubt.
So yeah, which one? Tell me.
Sir, if we have to calculate the maximum height, so we have to apply minus b upon 2a. Sir, but we have to apply minus b upon 2a after differentiation or before differentiation?
Can you relog in? Can you relog in? Because there is a problem with the voice. I am not able to listen actually. Just relog in.
Hello, sir.
Yes, yeah, I can listen now.
Sir, after solving, sir, I got after differentiation, y I got as 10
Yes,
Hello,
yes.
sir.
and
Sir,
x
now am
I
I
got as
audible?
4.
X you got us
4.
4. Yeah.
Hello, sir.
Yes, tell me.
Sir, if you have to calculate the maximum height of an equation, so we use minus b upon 2a.
No, if it is quadratic, then
I mean that only quadratic, then we use minus
yeah,
b upon 2a. Sir, but
yeah.
we use minus b upon 2a after derivation or to the actual equation.
No. See, the idea is if y is ax square plus bx plus c, if you differentiate with respect to x, what you get is 2ax plus b. So when you get this to 0, the x will give you. So this is the critical. This is the critical.
So we have to apply minus b by 2a in the actual equation.
So see, you can directly write here because after differentiation you are going to get this much only. So you can directly write x equals to minus b by 2a as the critical point, and if a is negative, it is maximum. If a is positive, it's minimum. That's it. So depending on the a and b side. So if you differentiate once more, what will you get? So the second derivative will be how much? Only 2a. So whether
Yes,
it is
sir.
maximum or yeah, it is dependent on sign of a itself.
Yes, sir, I asked it because sir, 10th one answer is 3 feet, that maximum height.
This is not height. This is the critical point. To get
Yes,
the
sir.
height, you have to substitute this value in the actual expression.
Sir, we will find height when we will get after the we will
Yeah.
put f of x as f
Yeah,
of
correct,
minus b by 2.
correct. Very good. So when you write f of minus b by 2, then this is the height. X is not height. This is the position at which the y is maximum. But what is maximum value? To get that, you have to substitute into the actual expression here. So I think that is the problem. You are getting the wrong answer. Is it okay?
Yes, sir. Sir, and sir, and can you calculate after, sir, that last sum? Can you calculate after you differentiated?
Which one? Which sum? The last sum?
Yes, sir, the margin one.
The margin one. Okay, so that xy was 50 first, and then I think x plus 4 and y plus 8 is the maximum area. So I can just say this a. So I got a equals to xy plus 8x plus 4y plus 32. So we got a equals to xy is 50, so we can add 50 plus 8x plus 4y. So this is 82 plus 8x plus 4y. Y is how much? Y equals to 50 upon x.
50 by x.
So I can write this as 50 by x. So we got a equals to 82 plus 8x plus 200 upon x. Now I believe that you know differentiation.
Yes, sir.
So if you differentiate, what will you get? If you differentiate, what will you get here? 0.
Sir, 0
8
plus 8 plus.
minus 200 upon x.
Yes, sir.
And if you solve this, you will get x equals to 5. And of course, minus will be ignored because we can't take negative values.
Okay, sir.
And therefore, the other part is easy, I think. So I hope you can get the other part. So y is 50 upon x,
Yes, sir. That
which is 10, now. Okay. And because the inner dimension is known to us, so outer dimension is how much? X plus 4, which is 9, and y plus 8, which is 18. Okay. Okay.
Yes, sir, I solved the 10th one.
Yeah. Very good.
Sir,
So now look at. I'll show you the third method. Okay. What is the third method of solving this question? So we have a equals to xy plus 8x plus 4y plus 32. Okay. And we have xy equals to 50. So let's differentiate both separately. So what is dA by dx? So you can d by dx equals to x dy by dx plus y, and that is 1. And then 8, and this is 4 dy by dx plus 0. This is called partial derivative. We are differentiating not partially, we are just differentiating with x. So you differentiate the first expression, you got this answer, something very big. And if you differentiate this one, what you get? X dy by dx plus y is 50. In fact, okay, in fact, we can substitute something like the dy by dx. We can substitute this entire term. We can substitute. In fact, so I think we should have substituted that thing in the beginning only. No, this will much. It will be lengthy only. So I thought it will be even easier, but no. So this is not going to be easy. It's going to be lengthy only. So no. Yes, let's go to the next question then. So next you are solving is 10. So who has solved 10 question?
Also, I have solved.
Okay, 10.
So the maximum height is 256 feet.
So we have s equals to minus 16t square plus 96t plus 112. And what they asking? Find its velocity when t is 0, a part, and when it's okay. So this is the height of a moving object vertically is given by this formula. This is the height and time formula. So of course the ds by dt is for velocity, because I haven't taught, but you can imagine. So velocity is the rate of change of displacement, which will give you minus 32t plus 96. So the first question is find the velocity at t equals to 0. So v as a function of t is this much. At t equals to 0, the velocity becomes just 96. This is the answer to the A part. The other part is find the maximum height. What is maximum height? So at a maximum height,
maxima,
at ds dt will be 0. At s maximum, and this is the other way of saying that at maximum height, the velocity becomes 0. So at a maximum,
v is equal to 3.
Yeah. So at maximum height, actually velocity becomes 0, or you can say the first derivative becomes 0. So you can say t equals to 3 seconds. It means at 3 seconds you will be at maximum height. So to find the maximum height, you have to substitute value of 3. So this will give you how much? Minus 16 into 9. It is 256. Okay, I believe what you're saying is correct. And its velocity when s is 0. Okay, that's important. No, that's a mistake. S is 0 will give you time. So when you solve for s equals to 0, you will get minus 16t square plus 96t plus 112 equals to 0. And this is a quadratic which you need to solve. So I think we can take.
Sir, I solved it.
Yeah, how much? T equals.
Sir, there are two values.
Uh-huh.
32 upon minus 32. That is minus 1. It is not possible. And second value is 244 upon 32.
This is simplify. You can simplify. No? I think this we can simplify.
7.625 seconds.
So first let me, for we can simplify further. So t square minus 60 minus 7 equals to 0. This is t square minus 70 plus t minus 7 equals to 0. So I think it's easy. If I take t common, so I'm getting t plus 1 into t minus 7. So t is minus 1, which is not possible, and t is 7. Sorry, this is right. This is not possible. So we got the time. So at 7 seconds, what is the velocity? So we have formula for velocity here. You have to substitute t equals to 7 to say the answer. So when you substitute t equals to 7, what will you get from here? Now velocity can be negative because it means it's going down. Velocity can be positive, it means it's going up. So that is not an issue.
So what did you ask?
What is the velocity when s is 0? So we got the answer s is 0 at t equals to minus 1 second and t equals to 7 second. Because minus 1 is not possible, so we will take t equals to 7 second. And when you substitute the value of t equals to 7 second into the formula of velocity, you will get the answer is minus 128. And the minus represents it is going down. So that is the physical interpretation of the minus here. So we got the 10 questions solved. Okay.
So I didn't understand. I do solve the B and C before you solved, but the first one, what is velocity? I didn't understood that one. So
Okay. Velocity is called the rate of change of displacement or the height, you can say here. So height is changing with respect to time. So at what rate the height is changing? So if you differentiate, it's called rate. So just don't worry. We are going to learn these things very soon. After this, the next topic is this one. So anyway, so maximum minima, we have learned how to do it. But of course, you will face problem in the difficult question and other problems. So that's not an issue. You just work it out, find the difficulty, keep on asking in the doubt sessions or tutorial sessions. Okay, get it clear from during the tutorial session or with me whenever it is possible. And then what I will suggest is keep on learning calculus. I'm not saying it's the end of the calculus. I mean, calculus will remain with you forever, even if you're going to the domain of computer science. Calculus is very essential tool. Okay, so calculus is those who want to go into the computational world, okay, of scientific research. They need to be very good with calculus because it's an essential tool actually. And if you love physics and if you love calculus, then you can do miracle in your life. So advanced physics is based on mostly calculus. So as you go higher in the in terms of qualification, the two parts of mathematics which is very helpful to most of the physicists. One is called the statistics, and other is called the calculus. So one should be good with these two, and of course you should be good with algebra as well. The least we use is what we use least. There's nothing which we use least, okay, because we use a lot of trigo also. Okay, so if you are going into the communication world, if your interest is communication, then trigo will chase you like anything. But of course, the trigo will not be the way it is. The trigo will become the Fourier transform. So trigo will become a different format, and it will be mostly computational way of doing it. So all the wave is sinusoidal. So sine and cos is the entire world of communication. So the concept of communication is built upon the concept of sine and cosine curve. Because if you look at the curve, it is looking at the like a wave, right? So curve of sine and cosine is like a wave, if you have seen. And therefore, the communication is all about a wave. and therefore there is a relation between these two. So things will change as you go, in higher cities. It's a very interesting world of physics and maths. Do not take either of it easily. Okay, so if you like physics, then you're supposed to like mathematics, because you cannot advance in physics without mathematics. So you have to be good with physics. Physics gives the real picture, and mathematics is mostly abstract. So when you learn physics and you know mathematics, you can actually understand maths even better than those who only know mathematics. Okay. So those who only know mathematics only know the abstract way of doing it. But when someone who knows physics and mathematics, they can visualize it. So you can convert even mathematics into something, a visual story. So that's very interesting part. So one must love math to love physics. Okay, so you cannot go separately. And calculus is anyway, it's very interesting. It's a tool. It's called applied mathematics. So you apply the basic concepts of mathematics into it, and you get something very interesting. So anyway, coming back to the other part of the story. So we have done with maxima and minima. Okay, so we'll see something called increasing and decreasing function. So there are two types of increasing function. I'll do everything here. So now, how calculus is so wonderful, you will also realize now. So let's say we have a y equals to fx, some random function. Okay. So we have I've done 4 graphs. So let's say I'm drawing the graph like this. Okay. So you can see in this first graph, we have some increasing part in which something is growing always. We have some called constant part, which means no growth, but it does not mean there is a decay. It's like no growth, and then again it's increasing further. So this is called non-decreasing function. The non-decreasing means if it will either grow or will remain constant, but it will never decrease. But if I draw a graph like this, we can see that it is always growing. So there is no question of even a constant value. So this is called strictly increasing function. So this is called strictly increasing function, and this is called non-decreasing function, the above one. Now, similarly, we can do something like this, like a roller coaster ride. So in this ride, the water park, you can see something like this. This is called non-increasing function. But if I draw something like this is called strictly decreasing function. Now, what is interesting? In case of strictly decreasing or strictly increasing function, one thing is very obvious, and that is the tangent. If you look at the tangent of increasing function, so you should look at the tangent of increasing function. If the tangent will, if you draw tangent here, and if you draw tangent later on, what you can see for sure, that tangent is becoming steeper and steeper, right? Can you see that? And also, if you draw for the non strictly decreasing function, the slope is becoming steeper, steeper and steeper. So there is a problem here. In the first case, slope is positive and becoming steeper. In the second case, it is negative and becoming steeper. What does it mean? Here, the slope is increasing. Can you see that? Slope is increasing. So the d by dx of slope, because it's increasing, so we say it's positive. The change of slope is positive. So as x will change, the rate of change of slope is, we say, positive. And slope is always positive. So here, if it is strictly increasing function, then the first thing is the slope is positive and the rate of change is also positive. Can you see that? Hello, hello. You guys are there?
Yes, sir.
So when slope is positive and the second derivative, that's the rate of change of slope, is also positive. When both are positive, we say it's a concave up. What is it? Concave up. So this is called curvature finding method. If a graph is having positive slope and also having the second derivative also positive, if both are positive, we say concave up. Now you can look at this here. The first derivative is negative and the second derivative is also negative. Can you see that? If we differentiate, okay,
Cave down.
yeah, so it's if it is also negative, then we say that this is concave down. So we have concave and convex. This is called concavity and convexity. So the first one is called concave up. Second one is called concave down or convex up. So you can also say or convex up. Or this you can say as convex down. So there's something called concavity and convexity, and a graph with second derivative value will tell you whether it is concave up or concave down if it is second derivative is negative. Now, if the slope is positive or slope is negative, but the second derivative is zero, what does it mean?
So
That from the
inflection.
if the slope is positive and second derivative is zero, it means slope is not changing. There is a slope which is positive, but it is not changing, so it's called the straight line. So every line which you draw, it's a flat curve, so you can say the curve is flat. So when this is zero, always, what I'm saying is, if it is zero always, then it is always flat. If it is zero at one point, then we say inflection, but if it is zero always, then what we say? Straight line. So when we have a graph which is changing from convex to concave, we have one point of inflection. But when we have inflection everywhere, what does it mean? It is everywhere flat. So if second derivative is zero, it is flat everywhere. It means it's a straight line, because the flat means straight line. Okay. Similarly, if we have the first derivative negative, and second derivative is zero always, it's a curve like this. Okay, so these are the straight line again, and these are making obtuse angle with the x-axis. So when the first derivative is negative, slope is negative, then it makes obtuse angle, and if it is acute angle, it's positive.
Sir,
You can see, yeah. Tell me.
So in the first situation, what you gave in the straight lines, uh,
In the first case, the first derivative is positive, its slope is positive, but the second derivative is 0 always. So second derivative tells us about the concavity and convexity. But if it is not a positive or negative, then we say it's flat, which means a straight line. So a straight line is also curve whose slope remains constant. And that is why the slope of the rate of change of slope is 0. That's simple. So we have discussed the meaning of second derivative, if you remember. Isn't it? We have discussed the second derivative meaning. Okay.
yes, sir.
Okay. So these are some ideas which we actually use to draw the graph. But of course, we are not going to draw some very complex graph. But I'll show you how to draw graph just by looking at it.
So
Yes.
can you give some time to copy this?
Yes, you can copy it. No issue. So when it's not only like about x and y, so when we have a function of any nature, and if it is said that the function is always increasing or always decreasing, then what you are supposed to do is you're supposed to differentiate and make it positive. So if something is always increasing and they're not asking the concavity or convexity, they are just asking increasing or not, you can use the first derivative test. When they ask the increasing along with the concavity, then we use the second derivative test. Okay. So second derivative test is negative. It means the slope is becoming negative. Done, guys?
So do we have to write that conditions also?
Of course, if that's the condition, that is the most important thing. Graph is of no use if you are not adding the condition. Okay, done. I hope so.
Sir, can you tell ki what is exactly that d square y by dx square?
D square. Okay, that is called slope of slope. First of all, you need to understand the first derivative is slope, right? The second derivative is that how slope is changing. Okay. Okay.
There is a third derivative.
Yeah, you can do third derivative also. That's not an issue. But if
So
you
what
differentiate
does
third,
that tell?
then yeah, so it will lose the meaning of the physical meaning. So beyond third derivative, there is no physical meaning. Like second derivative is the physical word, and third is the abstract word. So we don't know about the physical sense of third, fourth, and fifth derivative. Okay. So we said the third derivative as what is it? In physics, we say jar. Okay.
Is
So
it used in impulse?
no, this is just a name given, but there is no physical significance. We cannot put into some physics. So no laws can be applied here. That's a problem. So that's why we don't study the jar. Anyway, so coming back to the part which is related to physics. If you have doubt in second derivative, uh, I suggest you go back to the derivation part of calculus if you know the differentiation. And in the differentiation derivation, by the first principle, I explained what is the meaning of second derivative. So if you have a curve, in let's say just take a small example, take a curve, draw a tangent at some x, move slightly ahead called x plus dx, and draw another tangent. Just check is the slope increasing in value or not. Can you see slope is
Increasing.
increasing? So the change of slope upon change of position limited 0 is positive.
Yes,
Can we write
sir.
like this?
Yes.
And we know that something like this is write as d by dx of slope. And then d by dx
Slope
and
is
slope
itself
is
d
self
by
is
dx.
theta. So this is called the change of rate of change of slope. This we write as d2y by dx.
Yes.
Like,
Change in a rate of slope.
yeah, it's a rate like double. You are saying second rate, the rate of y. So y will first change at a rate called slope, then slope will change at a rate called the second derivative.
Sir, this rate is constant.
If it is constant, if the second rate is constant, if you have concave
No,
up,
sir. That.
yeah, it's positive means some number only, of course. So if it is positive or constant value, so it's up, concave up. Okay.
Hello,
And
So
sir.
if
I'm
it is
asking if this is constant, then after every tangent, the value will be same, sir, for
yes,
this
it, yeah,
rate.
if yeah, correct. If it is constant means it will change by same value all the time.
Hello, sir.
Yes.
Sir, I got disconnected when you started the d2x y by dx square.
Okay. So someone had doubt actually, so I was clarifying that doubt. If you have doubt, you can also ask. So someone had doubt that what is the d2y by dx square meaning. So that is what I explained, that it's a slope change, rate of change of slope. Okay. So let's wrap up this part. Okay, this is of not much use. So how we can use this concept to draw some difficult graph? Okay, some difficult graph. Yeah. So I use something called cubic equation, maybe bi-quadratic. Yeah, quadratic equation is fine. Yeah, let's say we have equation x power 4 minus x cube plus 3x plus 5. Now imagine you want to plot this graph. You want to plot this graph. That's very, very interesting. It's very difficult also. So I will differentiate first. I'll get something very bad value. So I don't know what will happen. But yeah, something like this. Then I will differentiate again. Oh, that's nice. So at least we can equate to 0 expression like this. So if I equal to 0 this and if I equal to 0 this is very difficult to solve. That's impossible in a way. That's cubic equation. Leave it. How to solve this? We can solve this part, which will give us you can take 6 common.
This is a situation of inflection, no?
Yeah. So yeah, this is situation of inflection, correct? So it means x is 0 is one answer and x is half is the other answer. So what I'll do is I'll plot a 0 and half, and then we know the wavy curve method. If you remember, it's like
Yes, sir, we
positive,
know.
which means beyond half it's positive answer, beyond 0 it's negative, and between it's sorry positive, and then between it's negative. What does it mean? It means beyond half it's concave up, beyond like before 0 it's concave up, and between this is concave down, and we have 2 point of inflection 0 and half. So I don't know how the graph will look like, but at least I have some idea about the nature. So concave down, so beyond 0 it's going concave down, and it's concave up, so it may be something like this, maybe something like a point of inflection. Yeah, that's maybe like this. Oh, it may be changing like this, and then uh, somewhere it may becomes again it's a point of inflection, so it will become a flat here, and then
Sir, I have one doubt.
yes,
Sir, I understood this all, but sir, how did you get that after half it is positive?
because it's a wave curve method. If you remember, if x is more than half, this will you can add x, and you can take 2 common, so 2 into x minus half. You can write 12 into x minus half. You can add 12 into x minus 0 into x minus half. So we know this 0 and half is the point where things will change, the sign will change, right?
Ah, yes.
Not for,
Ah, okay, sir.
no, see, now I haven't drawn the all graph. Definitely, I don't know whether this graph will be like this or not, but I have some idea that the graph should have this shape. So let's try to see in the GeoGebra how it looks like. So let me start.
So you first remove the x values by d2y by dx2. So after that you plotted the points by applying x values in and putting it in the uh,
Yeah,
putting in into the d2y by
Sir, this
d2
is
differentiation or
graph
direct.
for x raised to 4 minus x cube plus 3x, 3x
just
plus 5. No?
just a moment, just a moment. Let me do it. Okay,
Sir, got the graph.
just let me start first GeoGebra. Yeah, so this should open. It takes some time actually. In my laptop, my laptop is really filled with various things. It works 24/7, and so it is totally unhappy with me. Okay, yeah. Okay, now we are at GeoGebra. I'll be sharing the screen very soon. Yes. some time in the beginning.
So the graph you drew is for x raised to 4 minus x cube plus 3x
Yeah,
plus
just
5.
it has not started yet. Just a moment. It is initializing. The calculator is starting. Yeah. So now x power 4 minus how much? X cube.
Yes, plus 3x plus 5.
Okay, plus 3x plus 5. All right. So let's see how it looks like. Where is the graph?
Sir, it is upward after at 10.
Yeah, it's upward.
Sir, it is up somewhere
Yeah.
between 5.
Yes. Correct. Let me make it a small. It's something very narrow. Okay, this is not a good graph. So what I will do is, let me make it. Maybe I can make a 12 here. Okay, that's going to work. So 120.
The minima is coming near 5.
Okay, yeah, it's coming very. Okay, that is something. Okay, not a good graph to deal with.
So minima is at 3.5.
But this graph is something very weird. So what I'll do is I'll make it x square as well. So let me make it some square function to add, and yeah, so maybe this should help. This is something very bad in terms of graphics. Okay, so maybe I can do.
So still it is the same only.
Yeah, it's not happening. So that's really bad. Okay. Okay, actually the scale has changed. So maybe I have to change the scale. Settings. Okay, it has taken really big value. So x minimum. Okay, just wait. X minimum is minus 10. I will take x maximum is plus 10. And something is missing here. Yeah. So x-axis is y minimum is okay minus 50 and y maximum is 50. So maybe 20. That's fine. Yeah, now we are getting something like this. All right. So now you can see. Okay. Oh, I haven't shown you this one. Okay, fine. Okay, so now I have something good to show you. Anyway, so if I change
So
this,
what will be the equation?
just a moment. I'm showing you just a moment. Yeah. Okay. So what was our question in the beginning? Okay. Yeah. So I think we are getting the question that we're looking for, and it's really nice. Okay, let me show you. So to show you, so although it's I hope you can see now.
Yeah, so the same thing was coming with us also.
Yeah.
Yes,
So
sir.
if I zoom further, you can see that this is changing at 5. So the same thing which I drew at 0, its curvature is something like this. So I think what we had tried to explain, it's coming. Just you can see that things are changing at half. You can see at half it's changing the curvature from up to down. So something like this, down to up or up to down. So difficult to see, but we have changes somewhere here. Okay, so we have changed at 0. At 0, if I zoom this part further, you may be able to see it, but as of now, it's really difficult. Okay, so mouse. So let me zoom it further. And if I keep on zooming, then probably can see that the point of inflection will be appearing there. It's very minor inflection, so it's very difficult to see. So what it's this part is
There's 6 0.4 comma 6.
Yeah, so it's very difficult to see here exactly. But maybe I can change some value to that will maybe I can see just 3. Yeah, that's too much. Now you can see much more. If I just make it 3x cube, then you can see the curvature is changing 2 places, right? So 0 is somewhere perfectly, it's coming back, I think. At 3, it is changing the curvature. And also you can see it's changing curvature here. And you can also see it's changing curvature here. So we have points at which the concavity is changing. So it's going concave, convex, and so this is 0 is the obvious the point. At 0, you can see that it is a point of inflection in this case. So the second derivative test, if you do it now for the 3x cube, probably you can see the better answer. Let's see how much we are getting answer if I using the 3x cube plus 3x plus 5. Let's do it. So let's go back to the original share. Okay, with our board.
So I got the minima as 2.077 something.
Yeah. So now if I make it 3x cube, because that is what I'm trying to do there. So the derivative will be how much? 4x cube minus 9x squared plus 3. And if you get to 0, you get some value. And if I differentiate this further, this is 12x squared minus 18x equals to 0. And we can take 6 common. Okay, so you can take 6x common, what you get is 2x minus 3. So what are we getting is 3 by 2. Okay. So at x equals to 3 by 2, we are getting the maybe the point of inflection. Let's check. Is that at 3 by 2? Okay, where is 3 by 2? Okay, we have to see it. 3 by 2 is very far. Okay, it's somewhere here. Yeah, maybe you can see.
Hello, will you repeat sir what you did just now?
I'm just trying to search for 3 by 2 part. See, the graph is quite nice. It's changing, the inflection is there, right? So 3 by 2 means how much? At half?
1.5.
1.5. No? So you can see at 1.5 somewhere here, which is difficult to open. I'll just show you. Just a moment. So at this point, 1.5, there is a point. This is a point of inflection. The graph is changing, and at 0. See, there are 2 points of inflection. Can you see that? So graph is having this shape. You can see the shape of the graph.
Sir,
Just remember.
it has two, actually one minima which is right hand side. It is very down and the left one is little up.
Oh, wait. Your voice is cutting like hell. Okay, just a moment. Just a moment. I cannot listen to you at all. Anyway, just look at this diagram, and then let's go back to the our whiteboard.
So done.
Again, the same issue happened. The internet has gone, so that's why this was happening. Okay. Okay, no problem. So, anyway, so the idea of second derivative was to understand the where the graph is becoming concave to convex or convex to concave, and these ideas will help you later on in plotting some complex graph in mathematics. In physics, we have mostly quadratic and cubic graphs, and it's not very difficult to plot graph in physics. Most of the graphs in physics are asymptotic in nature, which means it will be either parallel to the x and y axis at some point. So today I will teach you something about the graph.
Sir, I have a doubt in the last what topic you D2.
Sir, I have also one doubt.
Sir, you first this derivative after removing the second derivative, the value of x you got the value of x. Then afterwards, with that value of x, you had to put that value of x in the first equation of y, or directly plot the points by that points. Hello, sir.
Okay, I think the issue has gone beyond my expectation, and so today I'll terminate the class here only.
Okay,
Maybe
so
I
sir,
have to
I have just
work out
one.
with my network.
Sir, I have one just doubt, but it is not
So
related
okay,
to
we'll not
this.
start something new because this is quite.
Hello.
Sir, after removing the second derivative, we got the values of x. So after removing the value of
Uh,
what we have to really do to plot the points. Hello, sir.
Sir, left.
Okay.
yeah, tell me what you are saying.
Sir,
Sir, I
this
was saying
we have got the value of x. These are the point of inflections. No?
sir, in that after removing the value of x, sir, what we have to do, sir? Hello, sir. Hello, sir.
See, I mean, I can't listen because something is really wrong with today's network. So let me end this class. You can just chat, send me a message on WhatsApp. I'll try to answer.
Okay,
Hello,
sir.
sir.